Federated Analytics and Federated Learning are two pillars of hereditary, so for us they are fundamental. The first one, analytics, is important because it allows us to query heterogeneous and distributed data sources without centralizing the data. When you have heterogeneous data, it means that data is differing not only because they are in different format, but also because they have different schemas, different metadata describing the data. And in this case, it's very hard to query such data because you run a query like, do you have any patient with ALS? The answer is yes, no, but the way in which you are querying your database is very different. If you have a relational database, a graph database, or any other kind of data model, but even if you have the same data model, the schema can be different one from the other. So how do you do that? And Federated Analytics is exactly designed for this. I can run a query over a common ontology, which means a common schema, and then map this query to the local sources without requiring additional work to system administrators or to the users. And this is a great advantage because I can query heterogeneous data sources, heterogeneous databases, obtaining a unified answer with a unique system.
Thanks to the hereditary federated workflows, researchers can run analysis on a set of distributed datasets. And this one allows, on the one hand, to run the analysis that they already are running, but on a larger scale, so on a larger population. On the other hand, this one allows to start to think about new analyses that are possible thanks to the comparison of people coming, for example, from different geographical regions. An example of analysis that is enabled by the hereditary data network is the extraction of information about blood samples from patients that have the same disease and visualizations of patterns of interest for doctors through interactive interfaces that allow to dig into the data and explore, for example, outliers or other specific patterns or set of patients.
For ALS patients, we can ask queries like, what is the average level of IL-6 in the blood of ALS patients showing an inflammation of the right frontal lobe of the brain? So we need to analyze brain images, blood samples, average the values across different hospitals, and we can do it. The results we are achieving will be useful for other realities because it's a very general infrastructure. You change the ontology of reference representing your reality, you can run completely new queries, you can train completely new algorithms, but maintaining the architecture. So you don't need to reinvent the wheel in the future. You reuse what we have already done, and you just plug in the specifics of your reality of interest. So you are changing the diseases, but you are also changing completely the domain of interest. It's not medicine anymore. That's fine. You can do it. Change the ontology, change the algorithms, but the mechanics to run them is already there, and you can reuse it completely.